Audio Jungle. Audio Jungle.
Today I will talk about the types of support now, because once we'll talk about the types of beam, types of load acting on the beam. Before that, I think we should be aware about the types of support. So here, types of support, right? Types of support, right? Now, if you talk mainly types of support. So first is nothing but see, first is nothing but very common, which is nothing but simple support. Okay, which is nothing but simple support. I must say simple support. Simple support. Now, what is the simple support? So it's a, if the beam rests simply on support, it is called simple support. Okay, and basically when the beam is what simply when the beam is rest simply on support, when the support is exactly 90-degree, yeah, then only beam will be stable. Then and you can keep that beam on the support. So for that reason, it is also called simply support. Okay, for that reason also it is called simply support. So you can say if the beam rests simply on support, it is called simple support. And in this case, the reaction at the support is at right angles. Okay, and the beam is free to move in any direction, obviously, because uh, you can move any direction in the sense x, y, z, not in z vertical direction not possible, but x, y at least you can move. I will show the diagram, it will be more clear. And it will also be able to rotate in freely. There is no resisting moment and all, right? So one by one we'll see. First we'll see the types. Simple support, then we have a roller support. By the word only can understand roller support. Uh, so in this case, the beam end is supported on rollers. Obviously, if it is supported on rollers, so one roller will roll, then definitely uh, your beam also can motion, you can say horizontally. Mm. But vertically that will not be possible. I will show the diagram, then it will be more clear. If I say it is free to roll, then obviously it's a frictionless, right? Anyway, this is the second one. Third one is nothing but, obviously third one is nothing but hinge support. Okay, also I can tell you, okay, I will divide in four parts then, because I thought simple support is common, but anyway, I have given the types simple support also. So now four types we have: simple support, roller support, and hinge support. Okay, hinged support, and then it's a fixed support. Fixed support. Right. Generally, we'll talk roller support, hinge support, and fixed support. Simple support, obviously, it's a type, but it's a very common. Anyway, so but we'll just discuss every supports here. Like we'll see all the supports, what is the motion, and what about the rotation, how many forces, reaction forces are acting for that particular support, and how many moments are acting for that particular support. Each and everything we'll see one by one. First, here we have a simple support. simple support, right? So obviously simple support, if you see, will not go so much in definition and all, that is not required, but one liner definition definitely will follow. So if the beam rests simply on a support, okay, it is called a simple support. It's called a simple support, simple definition. Now how it looks, so I'll show you. Suppose this is the beam now. Beam is nothing but horizontal structural member. This is the beam now, okay? This is the beam now. Now if I want to show the simple support, so for the simple support you can show simple support something like this. And similarly here also. This is what simple support for this beam. Now you very important point you need to remember, for the simple support, the reaction at the support is exactly at right angles to the support and the beam is free to move. Yes, this beam is what free to move in this direction as well as it can move in this direction also. It can move easily, no problem. And where is the reaction? Reaction is what? Exactly 90 degrees. See? So you can say this is nothing but 90 degree. Okay. So the beam easily can move. Okay. It is also free to rotate about the supports. Okay. It's also free to rotate. Anyway, so 2 points very important. Okay. What is that? Support at or reaction, I can write. Reaction at 90 degree. Number 2, free to move, okay, in the direction of its axis. In direction of its axis. One more point you can add. It is free to rotate. It's free to rotate about the support. It is free to rotate because we are not clamping that beam with the supports. It's a free to rotate, it's a free to move, but it should be along the direction of its axis, because if this is the axis, so along this direction only it can move. Vertically it cannot move, horizontally it can move. Reaction is what? 90 degree. These are the very important point for free support, those who are beginner, those who are first time learner. So this is very helpful for them, right? Correct. So this is all about simply support. Now we'll talk about roller support. If you say roller support, so again, as I told you, we are not going much more definition point of view. We are not discussing here. That explanation is important, but single liner. Okay. So the roller support also we can understand. Here we can write beam in is supported on roller Hence it is called as roller support. Okay. Now if I show the diagram, so how the diagram will be there, you see. Suppose this is the beam. Check. This is the beam now. This is the beam now. If I want to show this beam on roller support, so how it's possible, you can show by this way. Check. This is the okay. Here we have a support, something like this, and this is nothing but roller. We have a roller here, sometimes required in mechanical or machinery. This type of support required for the system. This is the roller. Okay, this is what roller. Okay, I'll show by different colors, so it will be more clear to you know. This is nothing but roller. It's rolling about its own point. It's rolling. Right. So also here, if you see the angle, so it's a 90-degree. Another diagram might be you have seen that piston cylinder arrangement. So multiple piston is what suppose moving. So sometimes this type of motion you might have seen. Suppose this is the cylinder, you can say, and piston will be moving something like this. So I just want to show by the roller support how that mechanics work. This is the roller here. It is rolling about this point, and it is connected with the link. This is nothing but link. So obviously that motion will be what in this direction, maybe motion in this direction or in this direction. It can also roll about the point. So whatever the uh, object is what connected with this roller, so obviously it can move. This type of support also called roller support. All right, what are the important points here? Number one, here also reaction is at 90-degree. Okay, reaction is at 90-degree. Number two, this is point one. Number two, roller support beam is free to move. Free to move. Free to move along the support. Free to move along the support. But it can rotate, free to rotate about these are the important point for the roller support. Okay, right. Here I can write here, this is nothing but roller. This is nothing but beam. Okay, done. Now we'll talk about another support which is nothing but hinge support, which is very special also. Okay, hinge support. So hinge support, best example at your home, it is available hinge support. Like door is what connected. If you see the frame of the door is there, and in the frame, uh, it is that door is what connected with the link, and that link about that support, single sided door I'm talking. Okay, even both side door also. So with the frame of the door is what connected with the link, and that link is about that link, that door can easily rotate. So that type of support called hinge support. You will understand easily. So basically the single liner definition of this hinge support is what beam. Uh, it is sometimes why it is called hinge, because uh, hinge in the sense it will not prevent the rotation. It can prevent the motion. it cannot move. If you see the door, that door cannot move once it is linked with the frame of the door. Okay, but it can rotate. Okay, so that hinge moment or hinge support. So hinge itself, the meaning is it's a one point about that there is rotation. A rotation is what possible actually. That's the mean of it. That's the mean of the hinge actually. Okay. Now, so at a hinged support or at the hinge in the beam uh, can rotate about the support, but it cannot move in any direction. That is the important point. Okay. So, and obviously it can develop a reaction in any direction to keep in stationary. Otherwise, it will continuously be moving. So it can develop reaction in any direction to keep the end stationary. If you want to stop the door about that hinge about the if you want to stop the rotation of your door about the hinge point, then what you will do? You will use the some obstacle for the door so that it can stop the rotation. Yes or no? So it can develop reaction in any direction to keep the stationary. Right? It can develop reaction in any direction to keep in stationary. Now, so if you say 2 3 points, I just want to write directly here. Point number one: a beam can, for hinge support, I'm saying, uh, for hinge support, I must write for hinge support, beam cannot move in any direction. Huh? Beam cannot move in any direction at what is the number 2 points? Number two is beam can rotate about hinge support. About hinge support, the beam can rotate. Okay, right. Basically, in previous two cases, that reaction was at 90 degree. Okay, reaction was 90 degree, but here it is not necessary that reaction uh, is at 90 degree. A reaction is at 90 degree. It's not necessary at 90 degree. It's not necessary here. Hmm? So here you can write reaction can be split into its horizontal and vertical component. Okay, means here if you see the reaction, you cannot split in horizontal and vertical because only one component is there, that is 90 degree. Vertical component is possible here. Okay, vertical component. If I want to show the reaction, if I just want to remove the roller and all, and generally I just want to show the reaction force, so reaction will be only vertical, just 90. This is my reaction force. See, this is the reaction. You can say a vertical, only vertical. There is no horizontal component of the reaction. Similarly here also, this is my reaction. Overall, this is my reaction, which is nothing but only vertical. But for this particular hinge support, it is not necessary that reaction will be only vertical. It can be with different angle also. Okay, and obviously if it is with different angle, then you can, for analysis purpose, you can split into different component, horizontal and vertical. So now I just want to show the hinge support, how it looks. So I can show you first the support here. See, this is the support. This is the support only. Okay. Now the reaction force can be at any angle. I just show this is the reaction. So two component you can take are V vertical and another is R horizontal. Okay. RH horizontal reaction force, and your beam is keeping on this hinge support. This is what beam. Because it's a hinge support, so you have to show by the one dot line, dot point. Dot means about this point that rotation will be possible. Rotation, it can rotate. Here it is clearly mentioned. It can rotate about its, okay, but it cannot move. So that's the reason hinge support also called as pin support. You also know, means any object, suppose this is object here and this object is what pinned here at this point, so this object will able to rotate about this pin point. This is the pinned point, or pinned or hinged. So if it is pinned or hinged at this point, this is the complete object and this is the hinge or pinned point. So about this pinned or hinged, that object easily can rotate. Yes or no? It can rotate about it. So moment you will get, okay, that rotation you will get basically, and rotation will be like this about this point. Hope you understood this. All right, this is all about the hinge support. What about fixed support? So we'll see fixed support here. Fixed support, because it's free to rotate. If somebody asks to you if it is free to rotate, then what will be the moment? So obviously there is no resisting moment. If I say this is point A, the resisting moment will always be 0 because it is free to rotate. It is free to rotate. That rotation you can stop that. There is no problem. You can stop. But for that, as I have mentioned, you have to use a stopper, then it will be stopped. So opposite, or you can develop any reaction force in any direction to keep it, keep this end stationary. If you want to stop that, then you have to develop one reaction force just opposite to that rotation, or just opposite to that motion of the beam. You just use a reaction force, it will stop. Otherwise it is always free to rotate about the hinge support. That's all about your door. I told you door is the best example of the hinge support. Door is what opening and closing all time about the hinge support only. Hope you understood. Now coming to the fixed support. If I talk about the fixed support, so what is happening actually in fixed support? See, each and every points here also you need to remember. This beam, basically, point number one, beam in this for this particular support or at such support, in the sense for fixed support, the beam is not free to move. It is not free to move. It cannot move basically. Second, at fixed support, the beam end is not free to rotate. Means it is not free to move, it is not free to rotate. Okay, now see, if you talk about the reaction also, so reaction force also can be at any angle. Okay, reaction can be at any angle, right? Why in case of the roller reaction cannot be at any angle? See, if put for the roller support, if you say reaction can be at any angle, then it will slip and it will, that beam will not be stable because it is the roller and support is what at any angle. So obviously it will roll down or roll up. If it will roll up, that time also beam will be unstable, and if it is rolled down, then again it will not. When that roller will not roll, when the reaction is what exactly 90 degrees, so that time only beam will be stable. So for that reason, in case of roller support, reaction is what at 90 degree. But because here at hinge support, even though it is not going to roll up or roll down, the beam can rotate or object can rotate about hinge support, but it cannot roll up or roll down. So that time your reaction can be at any angle. Yes or no? It can be at any angle. Vertical and horizontal, you can uh, I mean, resolve. You can take that two component. Now fixed support. So if I want to show you how that fixed support will be, so you see the diagram, it will be more clear to you. Suppose this is now beam. Okay? I just say this is what beam. Something like this. This is the beam. Now this beam, okay, this beam is what? With fixed support. With fixed support. So I can show you by this way also. This is also fixed support. See, this is the fixed support. In this case, the beam cannot move horizontally or it cannot rotate. It is not able to rotate freely. Free rotation is not possible, but once you apply the load, once you apply load at this end, suppose, so this beam will have a resistance moment because it is not free to rotate, so it will try to resist that. So one moment you will get here, that is resisting moment, just say 0.8. So resisting moment at A will exist because it is not free to, it is not possible for the fixed support, it will not allow free rotation, but still you are applying any load P at the free end, so this beam will try to rotate in this way, try to deflect or rotate in this way. So here at end A, because it is fixed support, so it will try to resist that rotation, hence resisting moment will come into picture. But if you talk about the hinge support, so there is like for the door, so for the door, the hinge support is not resisting that rotation. It is allowing that rotation. But still, if you want to stop the door, then you have to use a stopper at the end of the door or somewhere. But that hinge support is not opposing that rotation. The hinge support is what allowing that rotation. For that reason, beam can rotate about hinge support. But here, in case of the fixed end or fixed support, the end itself is not providing any rotation because it is fixed at that point. It is fixed at that one point. Somewhere in wall also you might have seen. Suppose inside the wall, one rod is what fixed to hold something. So once it is fixed, then obviously their rotation you will not get. No? So always remember, for the fixed support, you will have a moment, resisting moment. You will have a, obviously, because reaction force is what at possible at any angle. Suppose this is the reaction force R. So two reaction force, vertical and horizontal, will exist. Okay. So how many unknowns? How many unknowns you have here? At one end where fixed end is there, vertical, horizontal, and it's a moment. These are the unknown. You will get these unknown values you will get at the fixed support. If I say what is the unknown, what are the unknowns here for the hinge support? So obviously you can say RV vertical component, horizontal component. Also you will have, what about the moment? Moment will be 0. It's so unknown is what? Only two, vertical and horizontal at one end. Means there is no moment existing at the resisting moment. There is no resisting moment existing at the hinge support. Similarly, what are the unknowns here? So Obviously there is no resisting moment, so there is no resisting moment, 0. There is no horizontal reaction force, also 0. Only vertical reaction force is what? Unknown here. Okay. Similarly here also there is no, here also I need to write somewhere here, there is no resisting moment, m is 0. No horizontal reaction, that's 0. Only vertical, because it is acting at 90 degrees, so only vertical is what? Unknown at one end. At one end I'm saying, okay. Similarly, if two supports are there, so for both two supports, 1 reaction force will be there. So two reaction force. Simple now. Sorry. I hope this one is very clear. I'll show you all the points here. It's now, I think, clear. See, this is the simply support. This is the ruler support, suppose. This is what hinge support, and this is what fixed support. Okay. Now, if I want to show you that two different place, I am just giving the simply support here. So just say this is A and this is what B. So I have reaction only RA and RB. Suppose this is the roller support. Okay. So only this is RA at point A. And here obviously, because one roller support we have, so at least one simply supported or simply supported support you can take, so RB. Even though at roller support only one reaction force will be there, that's my point. If this is the hinge support, so how you will show the hinge support? I told you, you can show the hinge support by dot. This is the dot, so this is the hinge support. So here also you will get only uh, a reaction force, but one vertical and one horizontal. Similarly here one vertical and one horizontal. But if it is, this one is the fixed support, so if I want to show you by the fixed support only, so better I will show fixed support by this way. There is no dot. Okay, this is the fixed support. Now if you are showing dot in between, then it will be what it is called, it will be the hinge support, but you are showing only fixed. Okay, you are showing only fixed. So how many reaction force you will have? See, this reaction force, just say this is A, this is what? B. So RA vertical you will get. Similarly here you will get the RA horizontal also you will get. Now here also you will get RB horizontal, RB vertical, and obviously because these are the fixed support, so fixed support will try to resist the moment. So resisting moment will be like here and here. So this resisting moment will be MA and this resisting moment will be M. So at one end, three unknowns for the fixed support, that you need to remember. This is all about fixed. This is all about hinged. This is what roller. This is what simply support. That's all. बस यही था. Hope this one is very clear. So here we have a types of beam. See, so based on the support of the beam, we have a types of beam. Like first we'll see a diagram I will show you, so it will be more clear to you. Like we have a simply supported beam. So these are something like this. See, so this is what simply supported. Okay, wait, I should be correct this. I should correct this, otherwise it feels like overhanging. No? So simply support means exactly at the end that load should act, that support should act like this. This is the simply supported. Now coming to the another one. Coming to the another one, what is that? Overhanging beam. Okay. overhanging. How overhanging beam is possible? Simple. Whatever the support you are providing, both side for the beam. Suppose this is the beam now, and your support is what, somewhere there, but it is not exactly at the end. Somewhere you can show this is your support you have given to beam, but it's not exactly at the end. So this is called overhanging beam. This is called overhanging beam, right? Third one is nothing but cantilever beam. Cantilever. Cantilever beam. So this is what fixed support. Always remember, for cantilever, hinge support is not possible. Cantilever hinge support is not possible. Only fixed support is possible. This is the beam here. Okay. Now this is what fixed support. So this type of beam called as, this is what fixed support, and this is now beam. So this type of beam called as a cantilever beam. That load can be act anywhere. Hmm. Now propped cantilever. Suppose I told you, if beam is what fixed at one end and another is what free. This is fixed and this is what free. So this type of beam called as a cantilever beam. Then what is the propped cantilever? What is the propped cantilever? Propped cantilever. Very simple. Propped cantilever. Sorry. Hmm. Very simple. Just like only cantilever beam, we have a cantilever beam here. But it called as a propped cantilever beam when at the free end it is not free, it is supported. So it is simply supported here. Okay, and this is what fixed, and this is what simply supported. So this type of beam called as propped cantilever. Now if you see how many reaction force you will get, I mean one reaction force at this end also you will get, RB. Here obviously it is like one moment, resisting moment you will have, and this is the vertical, this is the horizontal, RHA, RV, A, and this is moment A. So these are the unknown for the propped cantilever. But for the cantilever, what are the unknown? We have only resisting moment. You just say A point, MA, then we'll have a vertical RVA and horizontal RHA. Here we will not get any reaction that moment at this end B. MB is 0. There is no reaction R. B is 0. There is no reaction force at the end of the beam because it's a free only. Right? But for the propped cantilever, you will get the reaction. Here you will get the reaction force. Okay, that will also be unknown. Right. This is all about propped cantilever. Now one last one is nothing but a continuous beam. Okay, so what is the continuous beam? Continuous beam. So continuous beam, generally you can see here, if it is simply supported beam, then how many supports are there? Only two at ends only. At the ends we have only support. But once it is continuous beam, fifth number, once it is continuous beam, then how many supports you will get? Multiple supports, more than one. Then it will be called as a continuous beam. Continuous. Continuous beam. Okay. So for the continuous beam, you can say this beam is nothing but this beam under it. Multiple support we have, okay, more than two supports. Till now we had seen only two supports. We had seen that in supports only here, but here also support can be provided. So this type of beam called as a continuous beam. This type of beam considered as a continuous beam. All right. Now